Hi, I'm Jennifer Waters, the director of the Nikon Imaging Center at Harvard Medical School, and today is a quick presentation on a very important property of lenses, numerical aperture. Numerical aperture is critical because it limits both resolution and the brightness of your image. In light microscopy, we define resolution as the distance by which two objects must be separated in order to distinguish them as separate from one another in the image of the objects generated by the microscope. And in epifluorescence microscopy, according to the Rayleigh criterion, that distance is equal to a constant, 0.61, times the wavelength of light that is generating the image, so the emission wavelength of light in fluorescence, divided by this property of the lens called numerical aperture, which we abbreviate as NA. Numerical aperture is marked on every objective lens. So right after the magnification, you'll see a slash and then a number, and that number is the numerical aperture of the lens. A numerical aperture is equal to n sine theta, where theta is equal to the maximum angle of acceptance. What that means is, if you think about the light coming from your sample, theta is the maximum angle of light that the objective lens can collect. N is the refractive index of the media that's between the lens and the specimen. So I think we can all agree that a lens is not going to be able to collect the 90-degree angle of light coming from your specimen. So the sine of 90 degrees is 1, and the refractive index of air in a vacuum is 1, slightly higher than that in the room. So many objective lenses have a numerical aperture above 1. So how is that achieved? Yes, Talley.
Raise the refractive index somehow?
That's exactly right, Talley. We use an immersion media that has a higher refractive index, like immersion oil. The refractive index of immersion oil and cover slip glass are similar, both about 1.5. Let's think about how refractive index could limit the numerical aperture of an objective lens. So again, numerical aperture is the maximum angle of light coming from your sample that the lens can collect. So light traveling at an angle through the cover slip, when it hits the interface between that cover slip and the media that resides between the lens and the cover slip, if the refractive index is different, you're going to get refraction. So that refraction can limit the angle of light that the lens can collect. Because immersion oil has a similar refractive index to the cover slip, refraction is minimized. So this allows you to collect those higher angles of light coming from your sample. So this is great. But, very important point here, a dry objective is designed expecting that refraction to occur. So if you oil a dry objective, image quality will actually get worse. So only use immersion oil with an oil immersion objective. Since the maximum angle of light that's collected by the lens increases with numerical aperture, that means that higher NA lenses are going to collect more light from your sample. That means brighter images, which we all love. If you compare two lenses that have the same magnification and the same correction for aberration, but differ in their numerical aperture, you'll find that the higher numerical aperture lens is much brighter. So think about the effect that will have on your experiment. If you choose the lens that has the lower numerical aperture, you'll have to compensate for that decrease in brightness in some way. So you might use a longer exposure time in your camera, or you might increase the intensity of illumination. That's going to cause more photo bleaching and more phototoxicity in a live experiment. Now that you understand how important numerical aperture is, you'll understand why it's important to report it in the methods section of your publications. So lenses should be described as the magnification, the correction for aberration, and the numerical aperture. For example, 60x plan apo 1.4 NA. Correction for aberration is the topic of a future video. I hope this has been helpful and that you'll always pay attention to the numerical aperture of your objective lens.